Well, good morning. I last spoke at this conference a couple of years ago and talked about IoT. And today I'm excited to be back to talk about sort of the continuing evolution or revolution of the overall end-to-end architecture, and as Jim said, the importance of the edge. And we've talked about this coming flood of devices, 50 billion devices connecting, driving traffic, and the number of devices is an amazing thing. But even more than that, it's not the devices so much, it's the amount of data that is just growing exponentially. And I think we've kind of thought about the internet up until this point as being sort of person-driven traffic. I'm uploading videos, I'm watching videos, I'm using Facebook or Twitter or surfing the web or whatever, and that traffic is continuing to grow. We're expecting to see 1.5 gigabytes of traffic per day per person by 2020, which is a lot. But that is going to be completely dwarfed by the data generated by devices. And a few examples of that. You look at a connected airplane, 5 terabytes of data per day generated by that aircraft, every single aircraft. A smart hospital, 3 terabytes of data per day. A connected factory, 3 petabytes of data per day. Imagine a factory that's got thousands of connected devices inside of it, and they're all generating data, and you're using that to improve your processes. A self-driving car, something that's probably been talked about more than these other use cases, generating 4 terabytes of data per day per car. So just an absolute explosion in the amount of data that's going to be generated. And obviously, with that amount of data being generated, you can't just send all that data to the cloud and do analytics on it there. And I'll talk about, there's a variety of reasons for that, beyond the fact that no matter how fast your network is, you just simply can't transport that much data, in that time frame. So this is going to drive change in some of the technologies that we're all working on. And as obviously I don't need to tell you, open source is the foundation of the end-to-end network that we have today, from the devices to the network to the cloud, and that's going to continue to be true. And we've got some great technology building blocks already, but there's new use cases and new requirements that are coming, and things that we all need to work on to enable this evolution to the edge. And I'll talk about a few examples of that and some of the things we're working on, and obviously looking forward to all of your collaboration as we work to build this new set of open source technologies for this world to come. So cloud computing up until now, as you're all familiar with, has mainly been focused around, we generate data with devices, my mobile device, we send that into the cloud where it's stored, and then we use compute cycles to do analytics and extract value. Lots of examples of this. This is the world that we're all very, very familiar with. And as we look forward, we're going to see that sort of storage, computation, and analytics capability extend out. It's going to extend out to the edge and to the things themselves. If you think back to those examples I gave of where this data is being generated, think of the autonomous car as a great example. That's going to start to look like sort of a mini data center, mini cloud on wheels. It's going to have all of those capabilities to store and do computation and analytics locally, as well as being connected to the cloud to do other computation and analytics. If you're in a car and you've got cameras and radar and LiDAR and you're gathering all that data, you need to make real-time decisions on how to steer the car. And you can't send that data up to the cloud and wait for an answer back on which way to turn. That's just not going to work, right? The latency requirement is way too tight to ever do that. And yet, of course, you're going to be using lots of cloud services as well. So you'll have that sort of rolling data center device that's kind of a combined edge device doing a bunch of computation that architecturally kind of looks like a data center. And you're going to need a lot of those same capabilities, but at a different scale. If you think about the connected factory or the connected hospital, you're going to have a whole collection of devices that live inside of those environments that maybe aren't capable of doing a bunch of compute themselves, but you'll see them connected to local edge devices that are going to do some local analytics. Maybe you don't want to send all of the patient data into the cloud because of privacy concerns. You're going to want to do some analytics on that locally, and then some of that data will go to the cloud. So we're evolving to this architecture where you've got storage, compute, and analytics distributed across the end-to-end network. And that's going to drive a need for some new capabilities and new technologies. And why is this coming now? I think we've talked about some of those reasons. As these new use cases evolve, the autonomous car, the connected plane, you've got this need for speed and latency and locality of compute that's going to drive you to do some of these functions at the edge. Security and privacy. Maybe I don't want to send all of my data into the cloud because there's privacy and security concerns. I want to be careful and thoughtful about what do I compute locally, what do I share out into the cloud. Scalability. With the incredible explosion of data that's being generated, you just simply can't transport all of that data into a central place. You've got to be able to spread that computation and analytics throughout the entire end-to-end network, which is also related to cost. The network bandwidth, even with 5G, is going to continue to be a precious resource. And so we need to use it carefully and balance what we compute locally versus what we send over the network. So we're starting to see this happen. This is already starting to come to be. But over the next 5 years, this is going to become more and more of a requirement, more and more common. You simply won't be able to deliver these new usages unless we're able to create this world of an end-to-end spectrum of compute and analytics and storage of data. So what kind of technologies do we need to do this? And we have a number of them already. Containerization and orchestration, AI and machine learning, we're using all of those already. And in those cases, this is more of an adaptation. We've got a great set of building blocks, open source technologies. But these are different use cases, different scale, different requirements. So we're going to need to do some adaptation in these areas. 5G networking is going to be an essential part of this. If you think about autonomous vehicles and how they communicate to the network and with each other, 5G is going to play a very big role in that. And as you heard from Arpit, there's a bunch of open source technologies in the software-defined networking space that are essential. You could never build out the 5G network using proprietary hardware and software. It's way too expensive and too slow. So open source is going to play a key role there. Functional safety is another, I think, really interesting space. We at Intel have been working a lot in and around the autonomous vehicle. And we're seeing this really interesting transformation. As the software workloads inside of the car become orders of magnitude more complex. Traditionally, the functionally safe systems in a car, think about the software that's running your instrument panel, your speedometer and tachometer, for example, which has to be safety certified. Those have traditionally been purpose-built real-time operating systems, really small footprint, simple. But the next generation of cars, the software complexity is so much bigger. And the people building those systems would love to use a fully featured, fully capable operating system like Linux. But Linux is not safety certified or certifiable today. And I think that's a big challenge for all of us, and we've started to work on this. How do we make and create an ecosystem around Linux where Linux can actually be safety certified and deliver all of the value that we've built in Linux and the kernel and the core libraries into an ecosystem that's really eager to have that capability but can't use it today? I think this is going to take years for us to actually turn into a reality. We're at the very beginning of that. Time-sensitive networking, again, if you're moving real-time data around a vehicle, for example, you need to be able to do that with latency guarantees and bandwidth guarantees. And then finally, how do we get all of these devices on board? I'll talk a little bit more about those as well. So let me click in and just talk about a few things that we're working on related to this space. So containers, we've been doing some work on containers for the last couple of years, and particularly looking at the security aspects of containers. So, Linux containers, you're running your containers on top of a common kernel, which gives you great scalability, very lightweight. But if that kernel is compromised, the security of all of those containers is at risk. So obviously, we've had virtual machines forever, for more than 15 years, and we've built inside of the Intel platform hardware capabilities to help make those virtual machines secure. So we had a couple of engineers, Arjen van de Ven and a couple other folks at Intel that looked at, why can't I apply this hardware capability against containers? And that essentially is what Clear Containers is. So it's a container that uses the underlying virtualization hardware to deliver security that's very similar to a virtual machine, but it's as lightweight and fast as a container. It's hosted at clearlinux.org. It's an open source project. And we actually have a demo of it out in the demo area if you want to see it in action in terms of how it can thwart some of the kernel exploits that could be used to attack containers. So a really cool example of how do I make a container more secure and take advantage of some of the underlying hardware capabilities. Orchestration. We've got orchestration solutions for the cloud today. We've been working on building a very lightweight orchestrator. It's called CHOW, Cloud Integrated Advanced Orchestrator. We did it initially and did some trials within OpenStack to show how we could scale up to very large numbers of nodes in a very fast time frame. But we're really focusing this on the edge use case now. So how do I create an orchestrator that's really well suited for this very lightweight, kind of small footprint context rather than a large data center? So another thing that we're working on developing, kind of looking forward at the edge use case, also hosted on clearlinux.org. AI and machine learning, we've got some great open source frameworks already, and our work has been mainly to plumb our hardware acceleration into those frameworks. So if you're running TensorFlow or Caffe or whatever your favorite framework is, that you can take advantage of the underlying hardware acceleration, whether that's on a Xeon or an FPGA or a purpose-built accelerator. And we're going to continue to do that. I think what's going to happen kind of uniquely at the edge is you're going to see these frameworks certainly running at the edge to do inference, but also combined inference and training as you start to look at how do I do more real-time adaptation of my neural network at the edge. Or maybe I have data in my training set that I don't want to expose because there's privacy or security concerns. So you're going to start to see these workloads running more and more at the edge and also together, both the training part, creating the model, and the inference part where you're using the model. And we're going to continue to work on making sure that these frameworks run great on top of our hardware platforms. 5G, we talked about coming in terms of driving a great amount of bandwidth. The other thing that's really unique about 5G is it's not only continuing to grow the mobile bandwidth, but it's also providing some really unique new capabilities for both massive machine-to-machine communication and also ultra-reliable low-latency communication. So you can imagine if you have a bunch of autonomous vehicles driving down the road, they can actually use this ultra-reliable low-latency flavor of 5G to talk with each other and to do coordinated actions. So we think this is really exciting. We're obviously very actively involved in driving the overall 5G standardization, but also working on a bunch of the open source software-defined networking technologies that are going to be needed to build these networks going forward. Time-sensitive networking. Again, inside of an autonomous vehicle, if you're moving sensor data around in real time, just regular old Ethernet isn't good enough. You need to have latency guarantees, you need to have bandwidth reservation, so you're absolutely certain that your critical data is delivered where you need it to go with the right timeliness. So there's been standards work going on here for a while in the AVNU group, AVNU, and we are working in the Open AVNU project, which is building out all of the Linux infrastructure that's required to fully support time-sensitive networking in a Linux platform. And then finally, device onboarding. Back to this world of 50 billion connected devices, one of the biggest challenges is how do I get these devices onto the network in a secure fashion? How do I get them on the network transparently and with zero touch? So we've been working on some new capabilities that use a hardware chain of trust where you can ship out a device, turn it on, have it be onboarded into the network securely and transparently without any interaction in a way that doesn't cause security vulnerabilities. A lot of times today this is done using a default password maybe, or it requires some human interaction. If you're going to onboard 50 billion devices, there can't be any humans involved. So we've been working on integrating this with, for example, the Open Connectivity Foundation and the IoTivity project. So kind of an ongoing project to solve one of the really hard problems in deploying all of these edge devices securely across the network. So there's a lot of work going on. already in this end-to-end space, and we're involved in driving some of the projects that I mentioned, but also working in many, many of the open source projects as we work to evolve the technology to support what we think is going to be one of the really big next use cases around edge computing. And I'm really excited to collaborate with all of you to make that a reality. So we've got, as I mentioned, in the booth, just outside the door, we've got a demo of the clear containers and some other cool demos that show some of this. Want to make sure you're aware there's a diversity and inclusion lunch panel on Thursday, a really important subject, so I hope you can all attend that on Thursday afternoon. And with that, thank you all very much.